In this video, we are going to explore C++ variant types. Specifically, we'll look at type-safe unions using standard : variant. Let's dive in. So, what exactly is standard : variant? It is a type-safe union that can hold values of different types, but only one type at a time. This feature was introduced in C++ 17 as part of the standard library. Some of the key features include type safety at compile time, which means that type-related errors are caught during compilation rather than at runtime. It also avoids dynamic memory allocation, meaning that memory is managed on the stack, which is typically faster. There is no undefined behavior when used correctly, making your code more predictable and stable. It also supports value semantics, allowing easy copying and moving of data. Let's examine the basic usage of standard : variant with some code. First, include the variant IOStream and string headers. Then, within the main function, create a variant that can hold an integer, a double, or a string using standard : variant, angle bracket int double standard : string close angle bracket. Let's name it v. You can assign different types of values to the variable v. First, v is assigned the integer value of 42. Then, v is assigned the double value of 3.14. And finally, v is assigned the string value of hello. The standard : variant can hold any one of its alternative types at a time. When you assign a new value, the variant automatically manages the destruction of the old value and construction of the new one. Let's see how to access the values stored in a variant. Include the variant and IOStream headers. Create a standard : variant that can hold an integer, a float, or a standard : string. Let's initialize it with the string value of hello. To get the current index of the variant, you can use v.index, which will output 2 in this case. You can also access the value with standard : get. For example, standard : string &str is assigned standard : get, angle bracket standard : string close angle bracket of v. For safer access to variant values, you can use standard : visit. Here's how. Include the variant and IOStream headers. Create a standard : variant that can hold an integer or a standard : string, and let's initialize it with the integer value of 42. Use standard : visit with the lambda expression to process the variant's value. The lambda function takes an argument arg and prints it to the console. This way, standard : visit applies a visitor function object to the current value in the variant. The visitor must be able to handle all possible types in the variant. This approach provides a type-safe way to process the variant's value without needing to know its current type. Sometimes you may need to check the type currently held by a variant before accessing its value. For this, include the variant and IOStream headers. Create a standard : variant that can hold an integer, or a standard : string. Let's assign it the integer value of 10. To check if the variant holds an integer, use standard : holds underscore alternative angle bracket and close angle bracket of v. If it does, print a message indicating it's an integer, and then output the integer value using standard : get. Standard : holds underscore alternative checks if the variant currently holds the specified alternative type. This provides a safe way to check the type before attempting to access the value, which helps you avoid exceptions from standard : get when accessing the wrong type. Now let's consider a practical example of using standard : variant as a return type for a function. Start by including the variant and string headers. Define a function called parseInput that takes a constant standard : string as input and returns a standard : variant that can hold a standard : string, an integer, or a double. Inside the function, if the input is equal to the string pi, return the double value 3.14159. Otherwise, if the input consists only of digits, return the integer value converted from the input string using standard : stoy. If neither of these conditions is met, Return a standard : string indicating invalid input, along with the original input. Standard : variant is excellent for functions that need to return different types based on conditions. This pattern is cleaner than using out parameters, error codes, or throwing exceptions for non-exceptional cases. Let's explore some advanced features of standard : variant. First, let's talk about standard : monostate. It is an empty class type used as a first alternative to make a variant default constructible. For example, you can define a variant with standard : monostate, standard : string, and int. Next is standard : variant _size. It gets the number of alternatives in a variant. For example, standard : variant _size _v of standard : variant int float will result in a value of 2. There is also standard : variant _alternative. It gets the type of an alternative at a specific index. For example, standard : variant _alternative t, angle bracket 0, standard : variant int float, double close angle bracket gives you the int type. Finally, we have valueless by exception. This is a rare state when an exception is thrown during assignment. The variant becomes empty and unusable until reassigned. You can check this state with v.valueless by exception open and close parenthesis. In summary, why should you use standard : variant? It provides a type-safe alternative to unions with no undefined behavior. It also avoids dynamic memory allocation by using stack-based storage. You get compile time type checking with standard : visit. It offers an elegant way to return different types from functions. It's useful for implementing state machines and parsers. Finally, it can be a cleaner alternative to inheritance for certain use cases. So include standard : variant in your C++ toolbox for more expressive and safer code. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.